right, so for our fourth example, we could do this with parallel or perpendicular. So I'm only going to show you one. So it says, write the equation of the line that passes through the point A at 2, 0, and it's perpendicular to the line XY, and they give you 2 points. So I'm just going to get a little visual. So if A is at 2, 0, and it has to be perpendicular to this line. That means I want to find the slope of that line, and I'm not going to plot x or y. So my slope is y minus y equals divided by x minus x. So I'm going to start and go forward. So 6 minus 0 divided by, you'll have to go forward again, -1 minus 8, which gives me 6 over -9, and that reduces to be -2/3. So that's the slope of line xy. So my new slope, in order to be perpendicular, needs to be the opposite sign and the reciprocal. So I know I want my slope to be 3/2, and it has to pass through the point 2, 0. So that gives me an x and a y to use. So we haven't written equations since I think Unit 3, so it's been a long time. So you have two choices, but I always use point slope form. So y minus y1 equals mx minus x1. So I know I'm going to plug in my slope, and I'm going to plug in, this gives me an x and a y that I'm going to put in for my subscripts. So I get y minus my new y, and then x minus the x that I know. Now, at this point, we need to distribute and solve for y. So y minus 0 just simplifies to be y, and I'll distribute 3/2 x, and 3/2 times -2 is -3. So now, since this is already isolated for y, this is the equation of the new line that I need that's perpendicular as asked.